Welcome to Math TV with Professor V. It's Monday, January 2nd, 2023, and here's the integral of the day. And since it's the first integral that I'm doing this new year, 2023, I thought it would only be appropriate to go with something nice and spicy. And I especially love this integral because it's oh so similar to the most recent one that I did, but changed enough that it requires an entirely different solution technique. So if you want to pause the video and give it a try on your own, feel free. Otherwise, I'm just going to jump right in. It is definitely deceiving. You might think, oh, it's trig subtime, but it's not because this x is not squared. So no. And then from here, you might just be stuck. And sometimes non-rational functions can be changed into rational functions if you make an appropriate substitution, which is exactly what we're going to do here. So we're going to make a u substitution to rewrite the integrand as a rational function, and then we'll go from there. How to do it? Well, we're going to let u equal the square root of x plus 4, which might seem a little strange at first, but just bear with me. Now, I'm not going to find du at this step here. It would be too messy. If you notice, I have plain old x in the denominator, and since in this substitution x is underneath the radical, I'm going to solve for x in terms of u right now. So squaring both sides, u squared is equal to x plus 4, which means x is equal to u squared minus 4. Okay, so that's what we will replace x with in the denominator. Now I need to figure out what dx is, and the easiest place to find that is right here, since u squared is equal to x plus 4. So differentiating both sides, derivative of u squared would be 2u du, derivative of x is just 1 dx, and then derivative of 4 is 0. So what does that mean for us? That I could substitute dx with 2u du. All right, we should be in business now. Watch how this all comes together. So we have integral. Instead of rad x plus 4 in the numerator, I'm just going to replace that with u over. Instead of x in the denominator, we're going to replace that with u squared minus 4. And then dx is going to be replaced or substituted with 2u du. Okay, take a second. Let that sink in. This was advanced for sure. Okay, now how to proceed from here. Let's clean it up. Always, I tell my students, just take those constants outside the integral. It'll make life nicer. So put this 2 outside, all right? And then notice here we have u times u. So what is that? That's u squared, last time I checked, over u squared minus 4 du. Okay, this looks much less terrifying because it's just a cute little rational function. Notice the degree of the numerator is 2, degree of the denominator is 2. We don't start employing techniques like partial fraction decomposition until the degree of the denominator is higher than the degree of the numerator, so we need to long divide. Here's another alternative to save you some time from long division, because I notice I just have that one term in the numerator. I can rewrite it. Check this out. So u squared over u squared minus 4 is the same as u squared minus 4 plus 4 over u squared minus 4. Wouldn't you agree? I mean, if I add and subtract 4, that's just adding and subtracting 0, right, from the numerator, so I haven't done anything illegal. And then from here, what you can do is group the terms in the numerator in such a way that you have u squared minus 4 over u squared minus 4 plus 4 over u squared minus 4. And then this saves me from having to do the long division. This is just going to be 1 plus 4 over u squared minus 4. And typically when I do this, I don't write all of this out. I've done it enough times where I can just kind of jump to the next step in my integral. So we've got 2 integral 1 plus 4 over u squared minus 4 du. Okay, looks very lovely. I mean, I couldn't be more thrilled. What to do from here? Well, hopefully we're all capable of integrating 1. Yes? Okay, great. And then now we can definitely work on finding the partial fraction decomposition for 4 over u squared minus 4. So let's take care of that now. Aside. So 4 over u squared minus 4. Let's factor the denominator. It factors into u plus 2 times u minus 2. So each of those is a linear non-repeated factor, so I'm just going to have constants in the numerator. A over u plus 2 plus b over u minus 2. So to solve for a and b, I'm going to multiply through by the LCD, u plus 2, u minus 2. And then now we have just 4 on the left-hand side. A times u minus 2 plus b times u plus 2. And then a couple different ways you can solve this. We can just substitute in, let u equal 2, and then 4 equals a times 0 plus b times 2 plus 2 is 4. 4 equals 4b, so b equals 1. Or if u is negative 2, then we have 4 equals a times negative 2 minus 2, that's negative 4, plus b times 0. So a is equal to negative 1. Very good. That means I can put this all together. Since a is negative, you might want to switch the order up, but I'll just keep it the same as we had it up here. So back to this integral, we have 2 integral of 1 plus a, which was negative 1, over u plus 2, plus b, which was positive 1, over u minus 2 du. Good? Very good. You should be able to integrate this very easily. So let's see how it all goes. From here, let's see. 2 times antiderivative of 1 is just u. Minus antiderivative, I put minus already because that minus 1. 1 over u plus 2, that's just going to be natural log absolute value u plus 2, plus antiderivative of 1 over u minus 2, again, natural log absolute value u minus 2, plus c. And then we definitely want to combine these natural logs. Since this one's positive and this one's negative, we can use our log properties and rewrite it as u plus ln of absolute value u minus 2 over u plus 2. The negative logarithms, those arguments go in the denominator, plus c. Okay, how do we like it? I love it. And then remember, originally we had let u equal the square root of x plus 4. So we need to go back and rewrite our integral in terms of x. So we have here 2 times square root of x plus 4 plus ln absolute value, square root of x plus 4 minus 2 over square root of x plus 4 plus 2 plus c. Do we want to distribute the 2? I'm leaving it up to you. Okay, I'm just going to leave it here. Let's box this bad boy. I think it looks lovely. So I hope everyone's 2023 is off to a fabulous start and that you enjoyed this integral. Give the video a thumbs up. Comment below what your favorite part of this integral was. And I'll be making more integrals of the day. Lots more videos coming your way. Check out the rest of my video lectures playlist if you're taking any more math classes this semester or you just want to refresh for personal enrichment. Subscribe if you haven't already. And you can also see what I'm up to on Instagram and TikTok at Math TV with Professor V. Take care, everyone.